Well, hello everyone. As our audience is still setting, I just want to share a brief personal observation. When you see a girl who's feeling all anxious and nauseated and upset about forgetting to pack her perfect dress for the event, it's pretty safe to guess that it's her wedding day or she's making her first doctoral presentation. And you guess which is the case now. Thank you, but too bad I don't have a flower bouquet to throw at you, but I have a presentation for you. I am Yi Cui from Simon Fraser University. I'm going to present Bringing Order to Chaos in MOOC discussion forums. This study was conducted by Dr. Alyssa Weiss, Jovita, Vytasek, and I. Also, we got help from Belinda Wanqijing on this project, to whom we want to say a big thank you. This research is part of our MOOCology research project led by Dr. Weiss. With MOOCology, we refer to the investigation of interaction in large-scale learning environment based on analysis of artifacts left behind by learners and instructors. In some way, our work is like archaeology in that we both try to restore and understand how human interactions happened in the past. And previous MOOC research have told us that the level of interaction in MOOCs are not so high, which also lead to lack of learning support, unsatisfactory learner experience, and also high dropouts. As a countermeasure, many MOOCs offer discussion forums, hoping for more interaction to happen. This actually could be a legitimate and probably promising effort, because ideally, discussion forums do foster social and responsive interactions. However, in a less ideal world, which we call the reality of learning and teaching in MOOCs, people's interaction more often look like this. Too many messages piled and mixed together regardless of their original purposes, making the discussion forum too confusing and overwhelming for learners to navigate. And of course, some measures have been taken to solve the problem or change the situation, for instance, setting sub-forums or using peer recommendation systems such as the number of views and votes for people to sort the posts. However, research found that they don't solve the problem. With all these questions in mind, our team is interested in using educational data mining and learning analytics to automatically identify posts for different purposes. And in particular, we are interested in finding discussions that are related to learning of the course subject and the learning materials, which we call content-related discussions. And for the rest of the discussions, which often are related to socializing, technical and logistical purposes, we call them non-content related. This binary classification would allow people who are interested in learning-oriented activities to find those opportunities more efficiently and save a lot of time. Next, I am going to introduce our research questions, the data we used, and also the methods and results. Finally, I would discuss the implications and what we are busy ourselves with right now. To begin with, questions. First of all, we wanted to know whether content-related discussions have distinct linguistic features than non-content-related ones, and whether those features could be used to build a predictive model for content-related discussions. How well will the model generalize to increasingly challenging and different, distant contexts, say from the same course to second offering of the same course, to a course on the same topic and to courses on different topics? And as the number of views and votes are so widely used as a means to sort discussion posts in MOOC forums, we are interested in knowing whether they are helpful for our purpose. And finally, for the concern of a live application, we wanted to know whether or how well the model would work through the length of the same course, like at the beginning, in the middle, and toward the end of the course? That's the questions we wanted to ask. Data. In this project, we worked with data that were delivered after the course is completed. That means we had to cook with what was available and shareable, and we had no control over forum design or course design. Also, we had very limited information about the learning context in which the data were generated. But I think that's a reality, a fact that many MOOC researchers have to deal with. Thanks to Stanford and the Open Learning Initiative, we were able to work with data from 5 different courses on 3 subjects. The first course, StatMath13. This is an introductory statistics course which had over 800 randomly sampled threads. This was used as the training set. StatMath14, the second offering of the same course, was used for cross-offering test of the model. StatLearn, a more advanced stat course, used for cross-course test. Then we got an introductory psychology course, which was used for cross-domain near transfer test, and a physiology course for cross-domain far transfer test. The 4 external data sets each had about 300 to 400 threads in them. And for this 5 courses, they had some similarity in their course design, but also some differences in the course design and design of the discussion forums. Next, I'm going to present our research method and the findings for we got with this method by going through our research questions one by one. First of all, the distinct linguistic features of content-related posts. Will we find them? To check that point, we first decided to analyze the starting post in each thread, because first, they reflect the primary purpose of the posters, and second, they set the primary direction of discussion in the thread. Then, we manually coded our starting post in the 5 data sets, and we got pretty good inter-reader reliability. The coherence kappas above 0.7. Then we extracted bag of words features using LAK'16 from these 5 courses. And then we found unigrams and bigrams as well as stop words were most helpful for our purpose, while parts of speech was not helpful. From the training set, we extracted over 2,000 linguistic features, ranked them by kappa, and then we took the top 30 features from the content-related posts and the top 30 from the non-content-related ones, put them together, examined, and there we have 60 different distinct words, features. To dig deeper, we took the top 60 linguistic features in the same way from all 5 courses, put them together, and examined in what contexts, for what purposes they were used. By doing that, we were able to identify 10 different categories of contexts and purposes. And here, I am presenting you the top features distribution by category. Here, each block stands for 1 linguistic feature, while each color here stands for 1 course. And here, you have the 10 categories. Now, by tracking whether the features originally were extracted from content-related posts or non-content-related posts, we found interesting pattern in the distribution of the features. On this side, categories here mostly consist of features from content-related posts. Well, on the other end here, we can see mostly the features in the same categories are from non-content-related posts. So there's some story happening here, and next we will figure out what it is. The first group of features we found are related to the course subject. And that is to say, in a statistics course, that would be words like probability, value, or mean. But this is not really that surprising, right? When people talk about The course subject, they use terms from this field. Not that surprising at all. But the interesting part is there are not many of them in the top features. Even if we take them out, we still have quite some features to play with. So what else did we find? We found features related to learning process, words like understand or example. We also found features that are question words like what, why, how, which. And we found connectors. These are the features that connect ideas and concepts like and, or, then, but. This is what we found on this end. Moving to the other end, we have features related to the course and tasks, such as finals, exam, video, assignment. Also, we had people-related terms, mostly pronouns. And we have terms for appreciation and greetings. Thank you, hello, hi. The categories in the middle didn't show that strong contrast, and these categories are for existence and condition, quality, quantity, effort, and action. So this beautiful, we call it rainbow graph. This rainbow graph actually answers our first research question, which is, yes, content-related discussions do have distinct linguistic features. Then, do we get to build a model? What we did is we built a logistic regression model and evaluated the model via tenfold cross-validation. We checked 4 different indicators: accuracy, kappa, recall, and precision. With kappa over 0.6 and the other 3 around 0.8, this model is a decent one. Then does it generalize to different contexts? This is where we bring in the full external data set. Again, we run the model on this full external data set and checked these 4 indicators. But to see the trend of generalization more clearly, we built these 2 graphs. Here we have accuracy, kappa, recall, and precision across these 5 courses. So in general, we can see through these 3 stats courses, the performance was steady. And when it comes to the near transfer course, psychology, it dropped a little and dropped further for the far transfer course, physiology. This drop in the performance could be accounted for with the change of subject matter. However, the influence of course design and pedagogy is also worth of investigation. Then, about number of views and votes. Well, you can make your guess now because I'm going to review the answer quite soon. To find out whether they help us, we first modeled with these 2, the number of views and votes, as additional features to the base model, and it didn't improve the model. Then we used them as standalone features for modeling. We got very poor result. So the short answer is no, they don't help. And the final question is, how well does our model work across different time segments in the same course? Well, what we did is we took the 4 external data set and divide each of them into 3 equal-sized subsets based on when the posts were created. Then we got 3 subsets for the beginning, the middle, and the end of the same course and tested the model on it. Here I'm presenting the model's performance across time segments in each course. Each data graph here, radar graph here stands for 1 course, and again we are looking at these 4 indicators. In each graph, the light blue area stands for the model's performance on the whole data set from this course, and the 3 different lines stand for the model's performance on each time segment. The biggest fluctuation in performance was seen in stat learn. And this may have to do with the fluctuation in the proportion of content-related posts in each segment. And it may also have association with how the course was designed, how the learning tasks was designed. But in the other three courses, we can see the model worked pretty steadily through different time segments, and that brings the answer to our final research question. So those are our findings, and what can we do about them? How can we use them to make a difference in MOOC learning and teaching? Here's the ideas. First, we could build a post hoc filtering tool to assist people navigate discussion forums. Take StatMat 13, for example. In that course, among the over 800 threads, only 48% of them start with a content-related post. That means using this tool, people could save more than half of their effort, reduce their reading load by half. And if you were at yesterday's closing keynote speech, that means we can take not just Friday off, maybe Thursday and a good part of Wednesday too, because 52% less of reading. And in addition to that, or based on that, we could also use the result to build a live tagging tool, which would recommend a label when the learners are composing a post. Or we could use it as a post hoc tool to correct inaccurate tags. The data collected in this process could be useful for further improvement of our model. And also, this tagging feature will also help learners to become more aware of what kind of activities they are engaged in. Last but not least, we could use this model to identify learners. It is possible that learners' engagement pattern in content and non-content related activities indicate particular learning goals or orientations. By identifying them, we give the instructors the opportunity to intervene as they see appropriate and necessary. Then that's the findings, based on which we now are pressing ahead on two fronts, both of which have data partitioning based on content relatedness as the pre-step for the research. The first direction is topic modeling, in which we hope to use topic modeling method to help people find information that are relevant to them in more refined manners. And the second direction is social network analysis. We hope to investigate whether social connections and academic connections influence learners' learning experience and learning achievements differently when they are taking a MOOC or other large-scale learning courses. So that's our findings. And with that said, I made our presentation. Thank you very much. We would like to take your questions. Thank you.
Okay, do we have any questions?
Thank you. Maybe just adding to your final remark about social network data analytics, how useful or how promising do you think if you combine it and using some features, general features like connectivity or centrality, to combine it with this topic related analysis?
I think it'll be quite promising, but first of all, we would like to see what kind of pattern we can find out of the content and non-content activities, because some previous study have found that the academic related connections help with retention, but we are interested in finding out if that is also true for MOOCs. The previous study are based on non-MOOC contexts, but for other features, in this study, we haven't been able to do that yet because we don't have that data provided, but it would be interesting to look at it when we get a model and try to refine it.
Other questions?
so more of a comment, but maybe that's also okay.
Yeah, please.
Yeah, it was very, very interesting to see these results.
Thank you.
And I mean, without being that systematic, I found that the approach that you have taken very convincing.
Thank you.
To identify these elements of speech that can be used as indicators. We have done something quite similar. We have used, in a certain context of a recently finished project on video-based learning, we have looked at Khan Academy comments. And the idea was first to extract or to characterize the comments by their semantic richness in terms of domain concepts. So you can have, say, a certain domain vocabulary that you can identify. And then we used AutoMap, which is a text-to-network tool. Nowadays, you could also use Jana Diesner's context tool. We used AutoMap, and then we found exactly that there were, among the non-domain concepts, there was a very interesting category that we called signal concepts. And they are the ones that have to do with explain, help, what is the difference between was very important also. And so it was striking to see that your learning process related concepts are exactly, I would say, a superset of our signal concepts. And of course, we came across more, it was more of an exploration that it was just exploratory, but very similar indeed. And I think we have used these concepts indeed to kind of characterize students' problems of understanding. So I think using the domain vocabulary in combination with these learning process related concepts, you can do a lot of even diagnostic things if you want. But again, I find that really very, very interesting.
Thank you. Thank you very much. About the diagnostic analysis, we are also interested in that front because we believe it really matters when our research findings are applied to help not just teachers, but also learners to improve their learning and also teaching. So I think this is a good front to work on. Thank you.
Other questions or comments?
Yes, please.
Yeah, I think the idea of looking at this in different courses and splitting things up is really important for the generalizability. I was wondering if there are variables, data about the students as well that might be possible splitters, even within courses. You know, students who are older, returning to education versus younger, things like that might also characterize differences in the patterns within those groups that could be helpful.
Well, for this research, we didn't have demographic data provided, but when we were doing this research, we also thought about how these findings could be combined with previous research on the subgroups in MOOC learners and find more about different patterns of learning. And of course, that would be promising. Yeah.
One of my friends made a joke about he wanted to filter that anyone who was under 20 years old would just filter out.
Thank you. More questions?
Sorry, if I recall correctly, that like the height, is this like the number of counts you saw a feature? Like on that?
Like this ones?
Yeah.
Oh, each block here is stand for one linguistic feature. So like here, when you see the higher ones, that means more features.
Yeah.
Yeah.
So my question would be like, red and yellow are,
They are,
I think, the
stand
same
for
course?
different courses.
Yeah. But
So
like
this would be Stat Mat 13, 14.
Yeah.
This is
Yeah,
the Stat
sorry.
Learn.
But like StatMat 14 is it like the same course?
It's the second
Social
offering
repetition.
of the training set.
Then I would think like it's strange to me that you have so much difference in like a course that should be basically the same, right? Because it's like the next year's iteration. So have you experimented a bit, like how good can you generalize with like those categories for a new course? So for me, this would indicate that for each course you have to calibrate quite carefully to be able to predict.
When you say for a new course, you mean?
If there's another course coming up and you want your prediction model to work on that.
Well, we haven't done that yet because we don't have the access to such kind of course design yet. But for the variance in the number of data between the first offering and the second offering, it may have to do the difference associated with the learning group, or how the discussion forum was managed and facilitated, as it was the second offering of the same course. Both the instructor and the TA might have different techniques and more understanding of the learning population that might have something to do with the result.
Yeah, and I'm just going to add one thing. This is showing the categories in which the top features fell, but these are only the top features. The full model, which actually showed exactly the same reliability from StatMed 13 to StatMed 14, Kappa didn't change virtually at all.
Yeah,
so this was more looking at the patterns, but so something might have switched between courses. You can think about different students, different years have problems with different things, or I don't know, some different word becomes cool in the lingo that they used to ask questions with. But this was just trying to look at the general patterns, but it doesn't have the entire feature set that went in the model. So that would be interesting. We could look at the full feature sets for each of them and see what the percent overlap is, and that would address your question maybe better than this graph. I'm going to check the time because we probably... we have time for one last question if anyone has one.
I couldn't find it.
Thank you for this. A real quick question. I might have missed this. I was wondering if the categories you derived, were those based on supervised or unsupervised techniques?
Supervised. We hand-coded the starting post.
Okay. In terms of automaticity, it might be a lot of fun to just do like a cluster analysis and see if it matches with the hand-coded as well.
Pardon me?
In terms of automaticity, it might be a nice idea to follow it up with like a cluster analysis to see if those categories come out statistically.
Could be.
So when you say cluster analysis, are you thinking you say here together?
Yeah. I'd be curious if you're in a large cluster analysis over all these word features, if those clusters together statistically. Yeah.
I wonder if it would, because in some cases the categories are similar kinds of words, but
Yeah.
they would be used interchangeably, maybe less than
Perhaps, but I think it would take out some of the potential subjectivity of like a qualitative analysis. And it might be interesting in itself as well as kind of a follow-up and to provide kind of a more of a, I don't know, a rigorous approach.
I think it would be very interesting to do as a comparison, but I think we come from an education background. I don't think we want to take our human data and use, so I think it would be nice to look at how they produced different sets and see maybe one is better than the other, but I wouldn't decide that a priori unless all they produce.
Oh, I should hope they would produce the same thing, and then I think you would have more of like a convergent validity, which would be great to see.
Thank you very much for listening on your questions. Thank you.
All right, thank you.